Good morning, or 2 a.m. or 5 p.m., whatever time you might possibly be watching this, AP Stats. This is your lesson for Martin Luther King Jr. Day, Monday, January 18th. So this is going to be the end of the unit. This is going to be on sample means. So we're continuing with the idea of sampling distributions, now just transferring to quantitative variables, which comes from measuring sampling means, which comes from measuring a quantitative variable. So real quick, a couple things that we're going to see here. Mean standard deviation, that's just a measure of center. That's a measure of variability. Sampling distribution of X bar, this instead of sampling distribution of P hat, this means the sampling distribution of all the sample means. And this, my friends, is going to be epic. This CLT is insanely important. So grip those seats, be ready to go. All right, number one, if we just look at these, would these result in a sample mean or proportion? So mean is going to be quantitative, proportion categorical. Do you think school should close if it's really cold? That's a yes or no. Proportion. How much time in minutes? I see units. Quantitative, mean. Just something to think about, because on this unit test, you're going to have to make those decisions. So as far as symbols go, the parameter is mu, the true mean or the population mean. The statistic is X bar, the sample mean. Definitely some continuity here, which is nice. Finding the mean and standard deviation of the sampling distribution, that's going to be the same. The 10% condition is still in play. You have to check that before you calculate the standard deviation, because we're sampling without replacement. Learning objective 2, use a normal distribution if appropriate. So this is getting into the shape. So for last week, we talked about categorical variables, and we talked about this large counts condition, having at least 10 successes and 10 failures. Things are going to be a little bit different here. All right, these two questions. I would take a look at these, read through them, and answer them. So why don't you pause the video now, read through these two questions, and answer those. Okay, for this first question, if it's unbiased, the mean of the sampling distribution should be equal to the population mean. So I don't care if you used all fancy notation, but the mean of the sampling distribution, the mean of all the sample means, if it's truly unbiased, should equal the population mean. And how can we get more precise estimates? Well, we can increase the sample size. If I increase the sample size, my estimates are going to become more precise, which is ideal. Okay, so we're going to look at this data from a high school in New York that has 49 seniors, so a very small school. This, my friends, is a great movie that I've never seen. I'm just going off of what Mr. Bruckman told me. The Princess Bride. It's supposed to be hilarious. It's on my to-do list at some point this year is watch that movie. If you've seen it, I don't know. Maybe you'll appreciate that. So let's take a look. Here is the data for these 49 seniors in this one school. So it's asking you just make a prediction. Predict what is the mean and standard deviation and shape of this population. This is the population distribution. So pause the video, go ahead and make your predictions. To me, the mean looks like about 170 centimeters. The standard deviation, maybe about 7 or 8, about 7. I'm just thinking in terms of if I go out 3 standard deviations from the mean, I'm capturing almost all of the data. The shape looks to be approximately normal, roughly symmetric, unimodal. A normal curve would be a decent fit. Now, if we talk about the parameters, what specifically is true about this population? Well, if we calculate the average, it's 168.96 centimeters. And I'm using the symbol mu, the true mean or the population mean. And the population standard deviation, sigma, is 9.6 centimeters. All right. So let's take a look at question 2. Imagine taking every possible sample of size 5. I'm going to ask you to think about this question. Why is that important that they tell you every possible sample of size 5? If you need to, pause the video and think on that. The reason it's important is if we do that, that's going to create the sampling distribution. Because if we take every possible sample of size 5 and we calculate the average height of those 5 students and do that and look at all those sample means, we're going to create the sampling distribution. So predict the center, variation, shape of the sampling distribution based on what we know. And then for the variation, did it increase or decrease? So here, if this is truly unbiased, the mean of all these sample means should equal the real mean, which is this 168.96 centimeters. The variation, the sample size, here we're looking at one individual student. Now we're looking at groups of 5 students. So the sample size is increased. So the variation is going to decrease. Sample size goes up. I get more precise estimates, less variability. For the shape, I'm going to predict that this is probably going to be approximately normal because the population is approximately normal. So if we look at how the distributions of the population on the top of this page and the sampling distribution are similar and different, they are going to be similar. They have the same mean, which is a measure of center, and they're going to have the same shape. This is very important. If the population is approximately normal, then the sampling distribution is approximately normal. That's going to be very, very, very important. Differences. Your sampling distribution has less variation because now we're graphing averages instead of individual values. Averages vary less than individual values. So let me bring up a, no, let's go back to last week. Okay. Here we go. Those of you who like 90s alternative, I was listening to some 90s alternative playlist here. Alanis Morissette bonus, if you even know who that is. All right, so here goes. Here's the the population distribution, approximately normal. And if I start taking samples, if I do a sample of size 5, there's my sample distribution, and here's the beginning of a sampling distribution. If I do this a whole bunch of times, what I'm saying is if the shape of the population distribution is approximately normal, then the shape of the sampling distribution, whether we take a small sample, size 2, that's approximately normal, somewhere in the middle, size 16, approximately normal, size 25, approximately normal. It's always going to be approximately normal, the sampling distribution shape. That's what I'm trying to show you there. All right, so let's hop back over here. Okay, summarizing on page 3. These formulas, just so you know, these 2 formulas are on your formula sheet, the green sheet that I've given you. I don't know, I said formulas sheet, but formula sheet. So when you're doing these questions, you should be thinking CVS. CVS, what is, because you have to describe the sampling distribution. What's the center? What's the variability? What's the shape? Then you could get into z-scores and calculating the probability. So we went through the center, the variability. If the 10% condition is met, then you can calculate the standard deviation. What's the 10% condition? Can you state it in general terms? Pause the video and see if you can. The 10% condition in general terms says this: your sample size must be less than 10% of the population size. Sometimes we will know the population size and we can literally check this as a condition. Sometimes we won't and we'll just have to assume. So for example, if I'm taking 7 tiles out of a Scrabble game, I just read a question the other day, there's 100 tiles if you play Scrabble. If I take 7 out of 100, 7 is less than 10% of 100. I can literally check that. But if I sample 500 high school seniors in the US, I don't know how many there are in the US, but I'm making the assumption is 500 high school seniors less than 10% of all high school seniors in the US? Yes. So it's going to be one of two. Why are we checking this? Great question. Can you answer this? Hopefully you can. Why don't you pause the video and think on it? The reason is because we are sampling without replacement. And that means our probability is going to change ever so slightly. But if our sample size is so small and compared to our population size, we say, it's okay. In the words of Mr. Switek, it's okay. All right, shape. We just talked about this on the previous page and with the applet. If the population is approximately normal, then the sampling distribution will be approximately normal. Z-scores, just your statistic minus your mean divided by your standard deviation, and then using normal CDF. Excuse me, don't use the shortcut. Make sure you're always using the standard normal curve, the 0 and 1. All right, let's go to the next page. The length of human pregnancies from conception to birth varies according to a distribution that is approximately normal. This is really important. The mean is 266, so this is from the population. This is mu, and the standard deviation is 16. This is, again, from the population. That is sigma. Find the probability that one, your sample size is 1. Randomly chosen pregnant woman has a pregnancy that lasts for more than 270 days. I don't need to go through CVS. This isn't like sampling distribution. I have a sample size of 1. So I'm just using that population distribution. I know it's approximately normal. The mean is 266. The standard deviation is 16. They said, what's the probability the pregnancy lasts longer than 270 days? That's what my population distribution is going to look like. I'm going to calculate a z-score, 270 minus 266, divided by the standard deviation of 16 is 0.25. Then I'm going to calculate normal CDF. I'm just abbreviating here. The lower bound is going to be the 0.25. The upper bound is going to be a large number, 999 or something larger. And I'm going to take my standardized mean and standard deviation, 0 and 1. And the area, or the probability in this case, is a little over 40%. So I'm going to pause the video here. I'm going to stop the video and I'm going to make a new video for the second half of this lesson. So if you have questions when you're watching this, you don't understand something, send me an email, please, so that I can make sure you're good to go before you start in on your unit test. That's due Sunday the 24th. All right, adios for now.